Welcome everyone to take 2 here of this accelerated 2D vector drawing. The first take on the main channel was of course interrupted by the TG3 hiccup here, recurring hardware nonsense in 2019, although I pre-seeded the interface, took it down and such, was usually helps, but today it didn't help, so here, thank you for that, Broadcom and Linux kernel drivers. Amazing stuff, maybe not. Today we want to talk about accelerated state-of-the-art vector drawing, because everything is not as state-of-the-art as it probably should be. And for this, let's take a look here. Also, this is to all the people who always think I have no clue about anything. It's not like I can live stream every day about interesting stuff and pull this out of my head here without any prior knowledge of 15 years of commercial professional software development and university education, like you post somewhere on Reddit and Phoronix and everyone talks to you like you're a baby and have no clue about anything, but whatever. Everyone already knows everything better, and in the end everything sucks. Thank you for that. So what are we talking about today? This what also other wonder when you Google on the internet, search on the internet, you find similar questions. Why have hardware accelerated vector graphics not taken off here? Exactly what I wonder. He's working on an app that involves real-time manipulation of vector paths at 60 frames per second, and surprised how little information there is on the subject. First he tried to implement it using core graphics but didn't perform adequate for his purpose, and then OpenGL, yada yada yada. And then of course once upon a time there was OpenVG exactly for this, open vector graphics, and he says practical, useful API. And however, that seems to be abandoned by the Khronos group. Khronos, of course, being the standard group that is also standardizing OpenGL and OpenCL and Vulkan for that sort. But all of them, OpenGL is for 3D graphics like in games and CAD applications. OpenCL is for general purpose computing, and Vulkan, of course, for the new non-fixed function OpenGL successor. Nothing really is for 2D graphics like here on this Firefox scene and such. And OpenVG would be the only thing, but somehow it never really took off. Also, few drivers were there, and the few drivers there were, others reported here proudly that this was stripped from Gallium, for all the fans of at Phoronix and such who always applaud when stuff is deleted, like SPARCstation support or 3D support for Matrox cards there and such sort of stuff. Amazing things when always everything is removed. Well done there on this. Regards, not that we want to make advancements here in this kind of developments. And this also explains why, like, you probably have the feeling Firefox often is really lagging on Linux. And you probably heard and realized even there video, the low-hanging fruits like video acceleration is not even enabled by default, or even to say optimization. So what is this about? Let's take a look. And I posted the links in the video description if you want to take a look and study this. And why do I make these videos? I have hopes that we do some education and you learn something and motivate people to work on this and improve the world, make everything better, because in my opinion this is really sad. In 2019 we have all the classic acceleration code deleted in Xorg, the XR acceleration for solid fills, and new stuff is not even there. And what once was accelerated, for example, here this old school 2D drawing is not even accelerated anymore because there is not even an API for this anymore. So yeah, everything a little bit depressing here in my opinion, and would of course be amazing if everything would be much more snappy and more amazing. So long time ago, 9 years ago or so, here on this article on Tom's Hardware, actually a really nice site, I have to say, there was a really good article about this 2D acceleration on Windows, and they made here quite some research. Windows, mouse or window, let's take a look here quickly, just for you that even other people, here is by the way the history, solid fills, you name it. What is the only from Windows 2 forward, does Windows really live up to its name? Yeah, so this is by the way how Windows looked, and the solid fills, this is by the way what I mean then with solid fills, like fill rectangle, draw lines and such sort of stuff. This kind of stuff the ET4000, S3 Verge, Matrox and such could accelerate. But again, even this, what even old classic X11 applications here could use, but even the drivers, the vintage drivers, acceleration not being possible anymore, deleted and really set. So yeah, 2D rendering like this, X, Y, you paint there with solid fills, fill rectangle, fill line, paint, fonts with mono bitmap fonts and such, with overlapping here, one window over the other, with clipping and such sort. And again, this kind of acceleration was removed from Xorg. This makes me really depressive. It's really sad in my opinion. So we don't even make advancements, we only delete what was once working, and even that is not used today anymore. And again, if this would be my project, I would not have deleted this, I would have kept it around and maintained it, but somehow maintaining old code and amazing vintage stuff. So yeah, this is of course here 2D acceleration, what some CAD application, some desktop publishing application would have done, would have utilized the graphic card, drawing here dotted lines, filling rectangles and drawing icons, everything accelerated, but of course not anymore because XR acceleration is no more, and polygons, lines not there anymore. And they did here really good research for benchmarking solid rectangles, fills and clipping and such, and found that even here, we skip a little bit over to here or something, that even back in the day, Microsoft has revamped the acceleration API, the driver stack for more transparent alpha blending compositing, and they found that even then, back in the day here, some cards did not accelerate this. So for example, here's some new Radeon HD 5000 back in the day, new card did not accelerate line drawing anymore, so much to that you buy new cards and the old stuff is even then dock slow, so exactly what I'm talking about. And should we really develop applications and driver stacks like this, that everything becomes slower and slower? What was once nicely accelerated and implemented is no more, in my opinion. Really set development, everything becomes larger and only slower, less accelerated. It's of course ridiculous. Once it was accelerated, and even that is not accelerated anymore. This is why we make this educational series and do the programming here on the Matrox and S3 Verge and Voodoo, and educate here how to implement this, because I have hopes that with our educational series and spreading awareness, we can get people, because obviously I can't alone work against the windmills, fight here windmills. What I can, because I already not only do a Linux distribution, I even have here an own graphics stack and even open source exact image, but actually this here is our own in-house UI stack, but even this is not hardware accelerated, which is why I do all the research also and how to continue with this. And I do a lot, but certainly I can't do everything myself, even especially if I get into microkernel. This is why we need here help from you and such. So best share, like and subscribe and spread the word. There is hope, however. So there was already a long time ago Firefox 4. You see how old this is. Firefox 4 from a really long time ago, 7-9 years or something here, 2010. So nearly 10 years, you name it. Hardware acceleration in Firefox, they talked long about this, and it's still not very much accelerated on Linux. Really sad. The difference, they differentiate here between content acceleration, content being here the website content or the terminal content or the text fragments, or here all our nice and shiny lines here with alpha blending, anti-aliased and such. And this is content, also CSS borders, 2D HTML canvas and all this kind of stuff. And then after creating the content, the lines and the text and everything, the tables and whatnot, then comes the compositing, basically blending all of this together with transparency and such. And this is also what the old cards cannot accelerate. Maybe the Verge could even theoretically maybe blitz this with alpha blending together in some sorts. Also maybe the accuracy and tethering is not amazing, but so this is also what Xrender is accelerating, the transparent compositing there, and not really much more. And this is here transforming this, potentially rotating also and clipping. And there is a nice list there you see on Linux. I'm not really sure if this is 100% accurate, because not really sure if Xrender on Linux can do content like vectorized lines, anti-aliased lines. I'm not really sure, maybe not. I would say actually that Xrender is for compositing here, but either they mixed this, they didn't know better, or they think OpenGL is better for compositing, but whatever. On Windows XP, this content would be none, so no anti-aliased lines, and Direct 3D for the rest, and Windows Vista and Up and 7 and such, 10 and so on. Direct 3D for actually really accelerated vector drawing, lines and alpha blending, and anti-aliased lines and such in text, and Direct 3D for compositing this together. macOS is actually surprisingly Quartz. Here's a one meaning Quartz is basically CPU only, and there is some Quartz GL GPU isolated for the Quartz 2D API. It's not activated in Firefox for now, nor in other browsers. Also, in general, this GPU acceleration for Quartz was never, as far as I know, enabled in macOS. Maybe so there was once an option you could in the defaults write Apple Quartz GL something enable, or what this was. Not even sure this is even, so this was never system-wide enabled GL acceleration, and I think it was even deprecated, not even sure if it's still in macOS. So much to that. It's really said even on macOS, the flagship of kind of UI work and acceleration, even there it was not hardware accelerated, so this is really so depressing. And it's even a decade gone, you know, it's not like we talk about this since yesterday. We talk about this in the computer science community for 10 years and nothing really much happened here, and this is why on latest Core i7 everything is still dock slow and not amazing, not hardware accelerated and so on. So yeah, that is a sad state. However, there is hope. Here's also others. John Novak, this is a really good blog post. He did here quite some research, the state, and yeah, he even titles here, even has here TechRand and Toolkit Trainwreck. So yeah, I'm not the only one who has such kind of thoughts. He has here some really good write down that can't happily develop on a Linux VMware desktop PC at home, blah blah yada yada, slow and whatnot, and so on and so forth. It's of course also partially, back in the day we didn't have virtual machines with good GL, 3D, whatever acceleration, but today we have a little bit. We also need really virtual machines for more 3D and such acceleration to really make good use of this. And he also took apart here some Nano VG and yeah, fail and state of the art. He analyzed here some applications, in my opinion, really good research. Also, if you're interested in UI design, some really nice looking samples here, in my opinion, probably if you're interested in such kind of nice stuff. And he gives here also some things also nice, like good looking and well done. What I also usually criticize, like super large 57 megabyte executable, so much to that. But this is renoise, yeah, whatever, executable total, yeah, but whatever. I posted the links already. In my opinion, here's some really nice looking design stuff. And this is of course, this is what I talk about. All of this would not be in a classic program, like regularly good old fashioned program today with Qt or GTK. Nothing of this or very little of this will be hardware accelerated. This is really set. This is not what we have graphic cards for, that they are idle around and don't draw anything for you. And the maximum that is accelerated is usually alpha blending here some stuff together. Maybe on Windows the situation is slightly better with Direct 2D or what this was, but yeah, otherwise Blender, maybe OpenGL or yeah, OpenGL based interface, modern looking, not a semi-prefer and so on. Yeah, maybe Blender is actually using OpenGL, one of the few things, and so on. You can read this in full if you're interested in this, but at last there is hope already, and this is already some time older here. This is already from some Intel developer from 2016, so even this is already 3 years old, and this is why I wanted to continue spreading awareness here. Fast UI Draw, UI rendering for GPUs only, from Kevin Rogovin, and this actually is really promising. And again, some talk from 2016. I'm actually surprised that I've not really seen someone using this, but it looks amazing. I'm slightly tempted to use this for our own stuff here. Usually I'm not a great fan of using other people's libraries, but I can't really write everything from scratch, and this is looking good and MIT licensed. So they have here draw tables of cells, background, rotation, moving, and so on. And he ported this demo to Qt, Cairo, and Skia for some comparison. This is here some picture of some Painter Cell demo, good looking 2D stuff, obviously, and anti-aliased, I hope, and such stuff. And here's some performance numbers of this port of the Painter Cell demo also to Cairo and such. normalized to Cairo CPU backend. So this is Cairo reference CPU speed as reference 1, and then Cairo GL even slower. There you see, yes, this is super hard. Why is this super hard? It's super hard because the GPUs are not even built for this sort of workload, rendering, accelerating this kind of vector graphics. And this is why not many people do this. If this would be super simple and straightforward, then of course more people would do this. And it's also said that NVIDIA and ATI, AMD, Intel have not developed their GPUs more for this. This is really also this, as I said earlier, OpenVG, Open Vector Graphics did not took off. This is really depressing that we have GPUs that for most desktop workload in Firefox, Chrome and whatnot are mostly idle, and the most they do is blending your transparent desktop together. Really sad state, which is why we need to do here some more. And I researched, so this UI stuff I've written, as I said this already, I've written this here over 10 years, although it's super small, but I didn't have so much more time. It's some like kind of 20% Exacode project here, kind of, that we now use for our portable stuff and some graphic demos in some sort. So if you want amazing UI, small, amazing and stuff, you can also contact us. Can't open source everything. So I've done quite some research over the 10 years also, and I'm really getting to a point where we really need to use some hardware acceleration, and maybe I use this fast UI draw. This is one of the most amazing looking stuff. Let's continue looking in this number. So Cairo GL is even slower here. To my surprise, Cairo XLib is faster. Not really sure what they mean with XLib. If this is classic XLib, I have somehow the feeling not, because classic XLib is probably not blending, alpha blending, compositing. So this might mean XRender, but I have not really a clue. At least this is slightly faster. Qt raster is the same, so maybe CPU or something. Qt GL even slower. There you see, if you don't do hardware acceleration right, then it's deaccelerating, just like the Verge there. 3D graphic deacceleration if you don't do it right. And this is of course, this is also what I mean with the GPUs of the last years were not made for this. They were only made for games and maybe a little bit 3D cut applications, although of course most people don't do CAD and only do games. But there you see what you get if you, and this is also when I only see NVIDIA. First of all, I hate NVIDIA for their not publishing specs and binary only situation, and then on top of this you don't have proper vector graphic acceleration. Also, I should, now that I speak about this, I should give NVIDIA credit for Google. They have some extension to GL. We even, not that this video breaks again as slow as this is here, NVIDIA GL path draw or something. There is some GL extension that, however, I think is not implemented in open source Mesa or something here. So there you see, not even coming up with Google NVIDIA developer, yeah, GPU accelerated path rendering. And this is even not sure if this is this one. I should actually, yeah, NV path rendering. Ah, right. Why did I Google couldn't find it because I typed GL. Of course, it's not an upstream GL extension. It is NVIDIA proprietary extension, because why not? And let's see. So this is from, do they have a date in there? For 2012 only, so you will see even this is relatively new and not many people are using this. So path rendering, and was there performance of, let's zoom in there, get rid of the table of content, and what do they have here? Butterfly something, NVIDIA, so there are some, do they compare it with Egg or something? But there you see, this is kind of course, all the graphics do not look like this, but they also certainly look like this and other kind of canvas. For example, this here is PDF in a browser canvas thing. So all of this, you see this is likely here, all of this selection and drawing and scrolling is likely highly unaccelerated. And what do we talk about here is, by the way, Direct 3D, by the way, various path rendering implementations. And yeah, maybe you also even get different results there based on feature completeness and bug level. And of course, you do not always draw your tigers in your software like this, but you also draw vector shapes here for icons and all the UI stuff, menus, and you name it, and here all the arrows and whatnot. This is all this kind of stuff that actually should run on the GPU, but today doesn't. So yeah, at least one little shout out exceptionally for NVIDIA, but this is not in Mesa because anyway, reasons. So Skia GL, not that fast either, and then Fast UI. By the way, actually I scrolled over. Skia GL slightly faster in this, but here so 9 times faster. Fast UI Draw, totally amazing. MIT license, really wondering why not more people use this. I'm really considering switching to that maybe. Also, yeah, slightly not, also for this, to be fair, we already use Egg anti-grain geometry, slightly older version 2.4 for BSD license here in our code, because we of course did not want to implement all the vector drawing here from scratch, but all the rest is here from scratch, so all the X11, Win32, UI, AppKit and UIKit, and this stuff is all native code, very small shim layer there, and then anti-grain and all the rest in between, and we do this all in Lua anyway, so all the Lua application code all of our invention there, and this is of what we theoretically would want to draw here. So conclusion, the more complex the scene, the higher Fast UI draws performs against other renderers. Reason, not simple. GPUs are for throughput and GPUs want bigger jobs with lots of the same work repeated. In contrast, CPUs are better able to handling changing workload and state. And this is of course why there are not more libraries, because this is really difficult to do efficiently, and why not more people do this. And yeah, thanks God some people here took a look into this, and here's a developer. Let's give him another shout out here because he's doing amazing work there, Kevin Rogovin. And thanks to Intel for, and this is the difference between Intel and NVIDIA and AMD. Here they publish here nice open source stuff, and what is NVIDIA doing? Thank you very much for the fish and nothing much else there, NVIDIA. And yeah, also, so this is really hard. As I said, GPUs are not made for this. GPUs are made for texturing triangles and not blitting here, rasterizing this passes here of true type fonts and tables and such sort. And yeah, you can read this paper here for all the details. For me, at least, this looks amazing. So what this is doing, it's, I say, aims to have currently Fast UI needs 3 pipeline stages for the GL backend states are for supporting the 12 Potter and Duff blend modes. So supporting all this Potter and Duff are, by the way, some very old paper, maybe 30 or 40 old paper of the first in the 80s of this kind of blending modes, like paint over, source over and whatnot, I guess, as far as I remember. And you can read the details here. Maybe I can make a dedicated video, otherwise it becomes too long here anyway. This video is usually, and then nobody watches those. And then of course here, hardware isolated clipping. Of course all this stuff should be clipped. Clipping meaning here like filling here until clipping borders of rectangles and windows and scrollers and such. And yeah, amazing work. It's open source here on GitHub, Intel Fast UI Draw. And surprisingly, I thought after 3 years I have not heard about this again. I only the last week took a look at this again. This is, by the way, the fun stuff in between videos. We do amazing state-of-the-art research. So if you wondered what Exacode is doing, you can also contact us for contracting us for amazing development research, consulting and all this sorts, because we have a huge, as you see, knowledge of 15 years of commercial development, open source and research and experience and such. And yeah, amazing work. I'm really tempted, although as much as I usually don't like to use others' code, especially for our UI stuff like this. But I can really not do everything, especially, well, this looks amazing. That's certainly really huge work that they've done there. Extreme thumbs up here for this. We need more of this. This is why I do the educational videos, because we need less of shouting at each other on Phoronix forums that everyone is the more stupid than the other, when I actually, as you probably see, I have some huge background in graphic and CPUs, GPU, operating system, drivers from left and right, top to bottom, kernel drivers, graphic libraries, and all sorts over the place, although not enough for some Debian people, not on the right mailing list, because maybe doing too much outstanding research and development here. Yeah, spreading awareness, because in my opinion we need really seriously more of the state-of-the-art work. It is ridiculous that today we have 2D programs here, highly unaccelerated. Imagine, of course, this is again a quad core with 8 threads, Core i7 from yesteryear, aging Mac Mini with a failing TG3 network card there. Nick, thank you very much, Broadcom, for that amazing experience. Not But yeah, imagine, yes, it is halfway decent, but as you see, often this stuff loads here slowly, especially because everything is busy doing everything on the CPU. And I showed already that often the browser is here more busy than what do we have today. Of course, right now, not on the most busy website, but when I go to, let's see, what do we have on my second channel, then we get here plenty of guitar videos or something. This is coming from being here on my secondary channel where I've not done much and YouTube proposes me all kind of random nonsense. But as soon as we go here somewhere, the web content here takes over, and then, as I always pointed out in my weekly news segment and such, as soon as you do something, the browser takes way more CPU cycles for rendering just graphics than here even OBS takes for compositing, snapshotting, video capture input, the desktop, and compositing this together, and video hardware encoding this with VA API, hardware accelerated. And it's of course ridiculous that the browser here, for some, especially as soon as some advertising comes here, maybe if we visit Phoronix for some good advertisement or something, then for sure this takes over here quickly, 100%. No shit Sherlock, 53%, because everything done on the CPU. Thank you very much. By the way, in other news, yesterday I live streamed about JITting C++, and the next day Facebook announces JITting C++ code. So much to all the people on forums always tell me I'm the most stupid, I know nothing, the biggest moron on earth for posting just GCC is getting too slow. Yeah, amazing for that. So much to that kind of JITting C++ code experience, although they apparently use this for my scripting instead of PHP, slightly different from what I wanted, but at least amazing to see that other idiots like me have similar ideas there and do as nothing else Facebook is doing, but at least we get set standard and JITted C++ code. I hope you learned something and enjoyed this, and if you are into this kind of things, you can see all the links to all of this fast UI stuff there posted in the video description. I hope you learned this. I hope you learned something and liked this, and I hope to see you soon for all the next amazing videos and research to come.